this month, I'm going to talk about the Telco Edge. You have first, before I start, you have the Q&A. I would say module. You can just post your questions. I'll try to stop like every like 5-10 minutes to get the questions and have them answered. If not, then I will collect the questions and then I will post that as a post after the webinar. Just quickly, for those who first time to I would say to meet me, my name is Karim Rabia. I'm currently a chief architect for one of the I would say the giant telco vendors. My background is actually mobile networks and the transport. So I had like previous roles in Nokia, Huawei, STC, Orange, and STC, again STC. So I I see the technologies from two perspectives. Like I follow the classical approach. So whatever content I say or I put in the slides, most probably it will have a reference, and I will always refer to that reference. So I'm a good, I would say, follower for the 3GPP, for IETF, for ITU, and also I have some good contributions in the standard bodies and communities. In addition to practicing the technology, working many years in the vendor side and also working on the operator side. So also I see the technology from the customer and the vendor side. So I try to make slides that actually I would say have a reference from whatever standards or community groups. But again, I'm trying to put some practical I would say content and some lessons learned and key facts. Let's start just quickly. Again, we have 1 hour. So I prepared some sort of a storyboard, okay, and I named that Road to Edge, okay. I'm trying here to explain how did we as a telco community or a service provider or CSPs or vendors, how did we reach like a conclusion that we need to go to Edge, and actually what is Edge? So as a start, I would like just to explain the legacy mobile network for those who I'd say not maybe familiar with that, because that's our starting point. So normally, and here I picked an example of a typical 4G and 3G mobile core. So we always divide like the network into two main parts: the access and the core. And that's actually the legacy name of the teams in any CSP. So the access is always like the radio part, the E node B, the node B, the RNC. These are like the modules constructing the radio and the access part. And it may take other names, right? In other department, in other CSPs, like it can have the access, the RAN, sometimes the BSS. So that's actually the name of the teams governing these modules. And we have the core. Delivering the core services, as you see here in this light blue color, like MME, SGSN, S-Gateway, P-Gateway. And you always have some sort of connectivity requirement between these modules, either between the access and the core, between the core itself, between the access by itself. So this is what we call the transport or the network or the transmission teams. And it all depends on what kind of connectivity that you are doing in which layer. Yeah, for example, you can have a CSP doing RNC SGSN integration via MPLS network, or SGSN MME via MPLS. So that will be the MPLS part or the network part. You can think of node B or RNC as the transmission part. But at the end, this kind of connectivity construct different departments and construct functional scopes. Other than that, other than the core and access and transport, and these are the backbone of any mobile operator, there are other domains and other important entities like the VAS, value-added services, like the OSS, like the BSS for service provisioning, BSS for billing, for marketplaces, for e-channel, for sales. So these are the domains that construct a legacy mobile network. So with that approach, and specifically from the 4G era, and that's like typically 2009, we had like some classical segmentation of the network. We have the access, and we have the core, and we have the service, either intra service provided by the CSP or internet or YouTube or whatever. what was significant in that network, that the core network, there was some sort of split between control plane and user plane. You saw these nodes like MME, right? Handling only signaling. Uh, so it was some sort of split, right? But there was no, I would say, split intra function. For example, you couldn't have SGSN or S gateway C and S gateway U. So at the end, CP and user plane processing was all in the network in one nodes. And the latency by that time and the requirements coming from the ITU and even the practical latency fulfilled by the technology, it had an average of 20 to 50 milliseconds. I made it a little bit broad because in many contexts, there are different latency figures. And even me personally, from my experience, I saw different latency figures. So I made it like for 20 to 50 milliseconds and mapped to what is there in the ITU and mapped to what is there in reality. It makes sense. So with that latency, uh, there was no reason to go out the legacy sites or the legacy COs that had been there, central office. So if you go back to 2009, we had the concept of site, right? Or a concept of CO, where it hold the core network like the SGSN, UGSN, the MSC, the media gateway. Most of these were centralized. And as you see, because of the broad latency requirements, there was no real motivation to go out of the border of a central office or the classical sites on the national level or even in the regional level. So that was the case in the 4G. And by that time, if you go to 2009, 2010, the term edge was not there. We were always using the axis. And again, the axis was pure radio, and the core network kept their place in the classical sites in the national level or the central level. With some, after a few years, we had many steps and an evolution. One of the biggest evolutions that we saw in the mobile broadband or the mobile core with the introduction of the CUPS or the CUPS, control plane and user plane separation, in 2017. So in 2017, and that was in R14, which is actually the release that was pre-5G. I mean, it's one of the 4G, 3GPP releases that was before the 5G. The concept of CUPS was introduced. This means that if you see the third bullet, that you can have the nodes split into S gateway C, S gateway U, P gateway C, P gateway U, TDFC, which is a DPI, TDFU. So we had this kind of split, and it was a sign that once you do the split, you can easily deploy or position the splitted part in any DC, right? So there is no coupling or obligation that you split and you put the user plane in the same site of the control plane. You can easily position the user plane at any site, keeping that the interface between them or the protocol between the control plane and user plane was standardized by 3GPP, by the PFCP protocol. So you see, it was a hint, okay, that you can do the split. And by that time, in 2017, that was very really coupled with the concept of edge. Why? Because back in 2015, there was an evolution of the standardization of the HCMEC, okay, European Telecommunication Standardization Institute. They came with the MEC ISG in 2015. But by that time, because the operators didn't see any kind of compelling reason to adopt the new industry and go to the edge, right? Because there was no use case. As I told you, the set of services of 4G and the end-to-end latency was very sufficient to be handled by the classical architecture. So in 2015, the HMEC was there. Also in 2015, there was an initiative called CORD. CORD was a central office restructured or re-architectured as data center. So from the name, it was an initiative to move the classical CO into a data center. So that was in 2015. And again, in 2015, most of us didn't see any compelling reason to go to the edge because there was no business use case and the investment was huge. But when 2017 came, and from technological perspective, we were able to do the split, this encouraged this encouraged the telecom tribe to start considering the next wave. What is the next wave? It was actually the 5G. So if the 4G didn't construct any compelling reasons to go to the edge, with the 5G, and I'm bringing here the famous IMT 2020, the 5G requirements from the ITU. You saw, for example, one of the aspects is the latency, right? So you all hear about the ultra latency requirements, right? So when the 5G came, and I put here a bit broad, with 1 to 5 millisecond 5G latency requirements for the UR LLC, ultra reliable and low latency use cases, it was clear that the classical architecture of the 4G will never serve this kind of use cases, right? Because you will never be able to get a 1 millisecond or even 5 milliseconds to the national sites or the core sites. And what even gave a boost for the direction to the edge, that the 5G architecture, it came out of the box already decoupling the CP from the UP, the control processing from user processing. If now you review the 5G architecture, you will find that there are nodes only doing control pre-processing, and other nodes like UPF only doing or handling the user plane. So that was really one of many motivations to go to the edge. And that encouraged the operators to start reconsider or embrace the MEC idea that came in 2015. And by that time, there was no adoption. So I'm just getting in the definition from the HC MEC. So in a nutshell, MEC, or the multi-axis edge computing from HC perspective, making use of the split of the core network. So it's pushing the gateway or the user plane on the edge, together with a set of edge applications with an intention to have a local breakout. Local breakout, it means that the user will start to get the service at the edge level. And for that time, the impression for that time that edge is the access. Well, in the next slide, I'm going to show you that it's not always the case. But that was somehow a quick, I would say, preview of it, why there was, how did we reach a conclusion that we need to go to the edge? Why was this was not there in the 4G, and why it is somehow coupled with the 5G, right? You always hear the edge with the 5G, but there were many motivations that were there, good efforts from HCMEC. However, I will not comment about if it's adopted or not, but there was a good contribution from HCMEC to push the telecom tribe to go to the edge. The core also give a good perception about how to change the classical COs into data centers. And then with the 5G cloud native architecture and having this kind of split, and you all know that it's based on containers, so it was easy to group all these facts and have a definition of the edge that I'm going to explain in the next slides. So let me stop here and have some questions and come back to you. Okay, so there are some questions about the availability of the slides and the record. So this time the slide will be available and the record will be available as well. Can you tell reference for 1 to 5 millisecond latency for 5G, mainly the ITU, the IMT 2020, plus some other content from GSMA and from the vendors. But the exact number is in the ITU. That's the reference for the latency for the 5G in the ITU IMT 2020. Okay, so let's go back now to the let me just close these questions and then we proceed. So I answered this one, then this one. How applications deployed at the edge adapt as per radio conditions change? That's a very good question, and it's a good coincidence that I'm answering that in one of the slides. Okay, so we continue. Now, a very important concept, and that's in my opinion, this is how you can deal with any definition in the community. There are normally two categories of terms of technology terms. One is that we can say that it's a standard term, and one is a community term. Okay, so standard terms, there are some specs in 3GPP, right? And even in HCNFV, just doing definitions. Okay, and that's why when you tell me NFVI, for example, okay, I can tell you NFVI, it is the totality of software and hardware infrastructure that construct the environment to host VNF. Okay, that's the definition in HCNFV. So that's a standard term, right? A RAN, a core. So these are all standard terms. And there are other terms, I name them community terms. Community terms, these are again technological terms or technology terms, but they are coming from vendors, from community, from open source groups, from influencers, from webinars, right? So these terms, they don't have a standard definition, but it all depends on the context that they were used in. And I can give you an example of a cloud native, right? You can see a lot of people saying cloud native, right? But what does he mean by cloud native? Like, for example, is it like a stateless network function, like a VNF? Or is the mass to be in containers? So what about VMs, stateless VMs? Is it about the architecture, internal architecture, having load balancer? So cloud native is a community term that actually having a definition coming from influencers, from the organization. So edge is exactly a community term. And in the next slide, I'm going to give you the flavors of the edge. Okay, all the terms used by the tribe, by the communities on to define edge. So you can hear a lot about telco edge, enterprise edge, near edge, far edge, deep edge, device edge. So it's the community term. So we have to be flexibly welcoming all definitions. We need just to understand the context. Okay. So I just here give like an X edge, and you can just remove X and put any term. So there is a way, or there is a mode. Let me use the laser here. There is a mode of naming edge with respect to the data center positioning. And I'm sure you all heard about the near edge, far edge, deep edge, and then device edge. So it's like a hierarchical positioning, and then giving names to near, far, deep. But if you ask me, far or deep, well, there's no standard definition. But you can see an architecture and say, okay, this is far, and that's near because that's nearer to the core site. So, but it all depends on the context. That's why it is 100% a community term. And there is a kind of naming when people start to name the edge with respect to the served domain or the business use case, right? So you hear a term like floating term like telco edge. So when someone say telco edge, you start to think, okay, most probably it is named telco edge because it hosts telco application, right? Enterprise edge, okay, so that's the edge providing the B2B or the enterprise part. Operator edge, so that's the edge belongs to the operator, not, for example, to the public cloud provider. So that's a kind of naming that is there in the community. And then there is a category that include all the community and marketing terms, right? Like the term edge box. It can be anything in a box. It can be an enterprise edge. You have the naming from for example, hyperscaler and from the vendors, AWS Wavelengths. So Wavelengths is a solution of the edge for Amazon. You have the ITSI-MEC. So ITSI-MEC, that's the vision of ITSI to the edge computing. M is the multi-access edge computing. And then you have another initiative from GSMA, which is multi-operator edge, having an edge, a common edge for multi-operators. And there are a lot of other terms. And there's always, the hybrid mode, right? So you can see in an announcement, right, that operator X succeeded to have a telco far edge enabled by AWS Wavelengths. So you have a lot of definitions, okay? You have a lot of definition, a lot of terms. Our duty is just to understand the context. What does it mean? Because if someone say far edge, this doesn't mean anything. This doesn't mean anything. You should interpret the architecture and understand, okay, why it's named far, because maybe that's the farthest point that they can go, okay? And the near edge, okay, that's the nearest, that's center to the regional ones. So I made this slide to give you the message that there are a lot of definitions, and you should focus on the context where these definitions are being used. So typically, and from our experience working on the telco edge, this is most of the cases belong to what I'm showing here. But again, I admit that there can be other use cases not following the use convention. So let me start from the right to left. What we have, I mean, without any edge in the story, what we have currently classically in any CSP is some sort of core sites or central DCs or national DCs. So you may call it site, and when someone says site, this gives some sort of a legacy impression. Like that's a classical site that used to host, TDFs and media gateways and this kind of classical things, working with SIGTRAN and this kind of SS7 and stuff. But nowadays, these sites are either replaced or restructured as a DC. So you always hear the term central DC or national DC. So these are the backbone of the network, hosting most of the core functions. And then going a little bit to the border or to the edge, you always hear the term near edge. So near edge, in a simple definition, that's the first hop after the regional and central DCs. It may map to the aggregation points, to the OLTs. It all depends on case by case on the operator side. But normally when someone say near edge, that's the nearest point to the regional and central DCs. And at the end, you have a use case. For example, if you are going to sell a certain product to the enterprise segment, and that use case required a 10 millisecond latency. Well, if the regional DCs can fulfill the 10 millisecond, voila, you have the case served by the regional. If you have the use case served by the near edge, then use the near edge. So that's why I always recommend, before giving any namings, before doing any investments, you have to understand the anatomy of your network. You have to do an end-to-end latency assessment to understand where is the spot, or where is the port, or where is the point of presence that you will deploy your edge, right? Because you might not need to go to a deep edge, while your near edge you can fulfill the use cases, right? Okay, so near edge maps normally to the aggregation and the OLT. The term far edge, and sometimes people use deep edge in the telco context, commonly refer to cell sites or the points. So that's a far or deep direction from the telco perspective, because normally the telco port starts with one hop after the terminal. So even people working on the mobile network, they know that. So we always like draw this mobile, and then whatever comes after the mobile, that's the telco port. So starting from the access or from the cell site, that's the deepest thing that the telco can go. So commonly, the near edge and the far edge construct what we can call a telco edge or provider edge. That's the common case, but I'm sure there are other contents from other maybe vendors doing different tracks, but that's from my experience and from my perception and I would say assessment that I did from various directions in the market. Other than that, we have the enterprise edge. So the enterprise edge, think of it, it's like an edge as in a box. For example, you can lease a certain enterprise, like a thin CPU, a thin server that include a full private 5G. So that's a kind of an enterprise edge. The UCPE, as part of the SD-WAN use case, the universal CPE, a kind of CPE that can host application, that's a kind of enterprise edge. And then we can go, you can go a little bit more deeper, and you go to the device edge itself, and that typically the IoT gateway, the devices, and some people put also UCPE as part of the device edge. And there you can start to hear terms like fog computing, but I would say fog computing is not really part of the telco framework, because again, as I told you, most probably the telco momentum stops either on the far deep edge or on the enterprise edge. So I end with one slide, and then I'll go to the questions. I just brought a simple definition that I personally like, okay? And that was, I think, mentioned in one of the blogs of the HCMEC in 3 years back in 2018. So that was from Alex Resnick, the chairman of the MEC ISG in 2018. Simply, edge is any location in your network where compute and related infrastructure platform software are offered that is closer to user than your default data center. So you remember the default data center, which was regional and central. So if you go one hop near to the user, then you are in the edge. And that makes sense, right? Because near edge, far edge, enterprise edge, device edge, you go one hop below your regional central DCs, that's the edge. So it's a very simple definition. So if you go closer to your user, other than going beyond your regional central DC, then you are in the edge. So let me stop here and have some questions. Okay, let me take one question. Does the Mac is standardized? Yes, there is a full there's a full ISG industry specification group for in the Mac in ETC Mac. So ETC is doing that. There's a question about, will there be a one-to-one mapping between G Node B and UPF to achieve edge? I think I will answer that in this slide, because the edge is a perfect fit for the CU and DU, coming from the Open RAN technology. So we see that most probably the end-to-end slice, for example, will host a CU user plane and a UPF. So yeah, there is a CU user plane and UPF somehow mapping in some cases. And then a question about the cups. About the complexity of the cups. Okay, and there are other questions, so please, just because we need to, I don't want to slip the, I don't want to, because we have 30 minutes. So let me answer this one. So the question about the cups, about the complexity of the cups in the LTE and UMTS. So guys, there was no real adoption in the market for the cups, right? Cups were there in 2017, but it was seen as a 4G feature. And by that time, most of the operators said, okay, we have the cups, but we don't have use case, and we are waiting for the 5G. So why can't we do like a full 5G cups, because we all know that 5G is coming with an implicit separation between control plane and user plane. So if you ask me, people were not keen to have the 4G cups and have it in the edge, because if you go to the edge, then it makes sense to have the 5G core there, not the 4G. So it's just a quick answer that yes, the cups were complex, and vendors took much time to support. Why? Because their R&D were focusing on the 5G. So if you are in 2017 and you have a 4G feature called cups, and in 2017 that was like one of the starting points for the 5G. So most of the vendors were focusing on the 5G, and that motivated the operators to apply the cups or to have the cups as part of the 5G and not in the 4G context. Okay, so Telco Edge environment, and by the way, this slide is extracted from GSMA Cloud reference model that I participated in. So what is the message here? The message is that, okay, the Telco Edge, let me use the laser pointer. So we explained that the Telco Edge is commonly coupled with the 5G. It's not 100% coupled. There is no really direct relation, but it makes sense, right? But as you see from the storyboard, we had to go to the edge to fulfill the 5G use cases, because at the 4G time, there was really no compelling reason to go out of our classical sites and position anything out of it, because we were 100% delivering the 4G use cases. So that's why it is seen as one of the ingredients of the 5G, because it has a good contribution and role in the ultra low latency and the eMBB use cases. If you go to the edge, then you have to have a local breakout termination, and that makes sense. That justify why the UPF, the gateway is there, and why the applications are there. Because if you go to the edge, the most probably you will have the local breakout on the edge. So what I'm drawing here is just a collection of use cases, and they are all explained in JSMA. For example, Telco Edge is 100% fit for the DU and CU. So if you have a POP in your network, a position in your network that you can place the DU and CU, and then have the latency, which we call the front haul latency, preserved, then that's a perfect use case. That's a Telco Edge perfect use case. But again, it's not a use case that will bring revenue, right? When you onboard the O-RAN, DU, and CU in an infrastructure, that's fine. But where is the revenue? The revenue will come from the enterprise products, or from the slice service that you're going to sell on the edge. For example, you may start to sell, for example, a slice for maybe a certain app. So that slice on a high level will consist of a CU user plane, a UPF, and a third-party application serving the segment. For example, a slice for mining, a slice for agriculture, a slicing for V2X. Okay, so you can play like bricks and have the right offering for the enterprise customers. For example, you can have also for consumers good use cases for analytics. You can have a video analytics right on the edge. You can also have a CDN. Okay, but regardless of the use cases, what we see now in the market, it's not actually about the application itself. It's about having a solution that may have some sort of a marketplace that enable the user to go in a public cloud experience, for example, like the user going to Amazon, and then select, okay, for my edge locations in Arizona or Atlanta, I want this application. Then I click on it, and then I get on the edge, serving my factory there. So that's the new mentality. You don't just sell a Telco Edge with a UPF in a box or a 5G in a box. No, you have to give your customers some sort of VASes, and not static VASes, not static value-added services, but you must give them some sort of digital interface that can allow them to go and deploy the application that fits for them. And not only that, you see the PaaS, right, in the slide. PaaS is a platform as a service. PaaS is a platform as a service. Think with me. If an enterprise customer, then he gets, for example, an edge slice from a CSP. And that edge slice consists of like a mini 5G, at least user plane, like for example, a UPF, and then a certain application from the CSP to the enterprise customer. But if you are providing a platform as a service to the enterprise customer, the enterprise customer himself can develop his own applications. So if you are on a AWS, for example, platform, and you sell AWS, then the enterprise customer, if they have the development skills of AWS, and you see a lot of certificates, on LinkedIn, so people now are really doing a lot of effort learning AWS and being certified as a developer. So if the customer has this kind of skill set, then the customer will be able to develop more application or more tuned application to their needs. So there are a lot of use cases that can be enabled by the Telco Edge. 100%, it will host the network function port, which is the UPF, and it is a perfect fit for the O-RAN, DU, and CU, plus edge applications. Edge applications can be anything. There are many use cases on the community internet, like for analytics, for CDN, for V2X, and for all industry segments. I will stop here before I go to the Edge Cloud Stack and have like a quick review on the questions. Okay, so one question about, is actually the near far enterprise edge is all about latency, or there are other use cases that have like other factors like security and ownership and this kind of thing? And that's a very really good question. So the first factor, for sure, it is latency. Okay, so latency is really a big factor on determining the POP's location. So for example, if it goes on like in a logical way, then the business department or the EBU in any CSP, they start to think of digital products, enterprise products, And then they go to technical teams, to procurement, tell guys, we need these specifications or this kind of capabilities to be able to deliver these products, okay? And then the technical teams, they do the assessment and say, okay, to deliver these applications or these products, we need to have this kind of location in that edge, near or far edge. But there are other factors, okay, determine where to position the edge. For example, in the Middle East, there are still many limitations about having an on-prem deployment at the cloud premises. For example, you cannot give a private 5G to the enterprise customers, right? Some other regulations, for example, that you cannot host two data for two private 5Gs at one physical host, okay, to avoid to have this kind of security isolation. So that's why the Telco Edge is the most favorable choice from security perspective, because you still own your data. It's still on your premise. You haven't gone to the level that you go to an enterprise edge or to even far beyond that. So yes, latency is one of the main factors, but again, security, ownership, the operational model is also one of the other factors. So I'm going to talk about the edge cloud stack from bottom to top. So guys, we all have cloud deployments like on-prem, telco clouds, IT clouds, private clouds. So what will be the difference now when we go to have this kind of deployments on the edge? So from hardware specifications, we started to see many aspects that actually differentiate the edge hardware specs from the others. One of them is the form factor, right? So we started to see like more models that have, for example, a 1U, not 2U, it's only 1U. We started to see like a very dramatic decrease in the depth of the server. So if I say average server can be 100 centimeter, 120, right? 80 centimeter. So in the edge, we see models from different hardware manufacturers that can go to 60 centimeter and 40 centimeter. So the form factor really is adapting to adapt to the edge use case. And even the outer body ruggedized, it can be like having like a solid body to protect the server from the environmental conditions that may happen at cell site. So there are a lot of new families from hardware coming from the new vendors. Sorry, from the well-known vendors like Dell, HP, and even the new vendors. Edge is very coupled with the accelerators, right? People working on that domain, they always couple use cases with accelerators. And for example, when you tell me gaming, then it's a GPU, right? Okay, we need GPU. And then ORAN, FPGA, caching, persistent memory. So there are a lot of accelerators that is there and built in the servers to support the edge use cases. So this is one of the aspects. From security perspectives, and people working on the mobile domain will relate. You know that eNode B itself, the eNode B in the 4G, to be registered as one of the managed eNode Bs, there should be some security handshakes to make sure that this eNode B belongs to the network, right? So the same case in the servers, there are a lot of security measures to be done on the hardware. Something like TPM, for example, Trusted Platform Module. It's like a microchip in the server that does this kind of authentication to make sure that server belongs to us and not an intruder in the network. And then last thing, and the performance and power. So there's some requirements to have high performance on the edge for some use cases like video analytics, artificial intelligence engines on the edge. But on the same time, the power consumption and the requirement there should be less than the core sites, because there are no real power, I would say, sources like same in the central data center. So we see in the market a degradation in the power requirements on the server of the edge. So with all these factors, if you now go and then browse the data sheet of any server provided by any vendor for the edge, you'll find that really there are like major differences from the ones that being used on the central sites. On top of that, as a cloud offering, what does the edge should provide? So initially, we had the understanding that from cloud offering perspective, we should support infrastructure as a service, like VM-based hypervisors, containers on hypervisors, and then containers on bare metal. But I made that in gray because nowadays we see a lot of momentum to go for bare metal containers. So I kind of scanned all the 5G solutions from all vendors. So most of them are container. All the edge applications are lightweight. It's a bare metal container. So you should provide container as a service, and then you should have an SDN capability. And here I'm not talking about a certain commercial product. I'm talking about the capability of having a software-defined networking. Either it is provided natively by whatever container solution is provided, or by any kind of a backend that can fulfill the software-defined network. And PaaS, this is something that we are looking on. We believe that the solution on the edge should provide a platform as a service. And under the name platform as a service, each vendor defines that differently. Some people see that if you provide a solution for FMPM, configuration management, backup and restore, that's a kind of PaaS, that's fine. Some people provide a real PaaS for people to develop their application, so that's again a PaaS. Some provide database as a service for 5G, so that's a PaaS. So, but the PaaS as a capability should be there. And then on top of that, the ideal applications for the edge, 5GC is one of them, definitely 5G core, the IoT, the vRAN, CU, and DU, and then the CDN, the CDN as one of the use cases for consumers. But I would like to stress on one point. Again, I would say that the certified application or the marketplace is really one of the main requirements now in the market nowadays. So I don't get a static stack as an enterprise customer, and then I get a 5G core from your side and an IoT application. No, I need to have the flexibility at any time to start adding applications and to mobilize application. Like now I have like a factory in Toronto, and then I open someone in India and maybe in Egypt. So I need to deploy a full list of applications. Like you have to give me a complete portfolio, and then in a zero-touch provisioning way, I can deploy applications in different edge location. And I will show you that in the last slide. And that's the main aspects about the AWS wavelengths offering. And I'm giving the example with Verizon in the last slide. So that's an important, I would say, important brick in the overall edge solution. So do you have the stack? Then you need to have a management stack or orchestration stack. So you can start to have controllers. These controllers either centralized, managing remote compute nodes or workers, or it is distributed. So controllers like Kubernetes, like OpenStack, like whatever. You can have orchestration stacks. So that orchestration stack can be a new orchestration for the edge introduced as part of the edge solution, or you can extend the capabilities of the orchestration stack in central sites to the edge. I'm going to show that in a while. And then you have to have a full operational tool set for fault management, performance management, configuration, for security, backup and restore. And this kind of operational tool, most probably, they must be integrated with your OSS for the holistic, I would say, visibility on the network. So that's the cloud stack. We have 12 minutes. So just a quick informative architecture of the edge host, which is the edge POP from HCMAC perspective. So you have here like a set of applications that are going to be on the edge, and most probably you will have the 5G user playing on the edge, and you have something called mobile edge platform. This mobile edge platform is providing services for the applications. So it looks like a platform as a service thing. It's not a directly mapping, but there is a platform that is doing services for the applications. And then there was one question about how these applications get to know the radio conditions and how they can adapt. So for example, from HCMAC perspective, they said, okay, DUCU, okay, that's a perfect fit for the edge host, right? So why can't we do a logic here that this mobile edge platform can get feed from the DUCU about the radio condition, radio congestion, and then can provide this information to the application, and based on that, the application can have like different logics or different behaviors. So that's the idea from HCMAC. that you have something called mobile edge platform, doing platform as a service, have some integration with the CU and DU as one of the use cases, and these APIs are defined, by the way. So you get feeds and inputs about the congestion and radio state, and then that kind of feed is conveyed to the edge applications to have, different scenario or different different directions. I have to move fast. I'm sorry. So we have 3 slides. One of the well-known, I would say, the not debate or confusion about the edge is actually how to start. Okay, for telco operators, for CSPs. So most probably 2 years back, two architectural logics were proposed from the vendors. One is called standalone edge clusters, and standalone edge cluster. This means that, okay, you have a centralized cloud that have controllers and compute or worker nodes, OpenStack or Kubernetes or whatever. And then on the edge, you deal with each edge pop as a separate entity that can have like a controller or compute, like a mini controller and mini compute. So that this is what are called standalone edge cluster. And let me just remind you that the investment on the edge can be huge, because edge can be like thousands, right, of sites, hundreds of sites, thousands of DCs. So it's a painful investment. Okay, so you cannot just go and invest without making sure that there is a business case and there is like a well-defined revenue stream. The other option, and the name here is coming mainly from Red Hat, DCN, distributed compute nodes. This means that, okay, you can have your central cloud having controller and compute and workers, and you can start deal with edge as remote workers, like remote compute nodes, remote worker nodes in case of Kubernetes. So these are the two well-known approaches. There are maybe other approach like they call the device edge, which is one server that hosts everything. But I'm just focusing on these two because the CSPs are always evaluating these two models. And I'm here doing an assessment. We can do it together actually. The standalone edge clusters and the DCN. So from footprint perspective, CSPs see that, okay, I don't have to invest or to reinvest on controllers on the edge, and because that's most probably costly. So from footprint perspective, the option of DCN is really much better, where you can just deal with any remote POP as just adding a new compute node, like an expansion. From high availability and service impact in case of failure, so you see that the failure of centralized site in the standalone edge cluster, this doesn't mean that the edge sites fail. Okay, I know that centralized that center fails, that's a huge thing, but let's think about of disaster recovery or a disaster mode. DC is totally out of service. So if you lose the central sites or DCs, you don't lose the edge. While here in the DCN, if central DC controllers is out, then خلاص, you lose the connectivity with the edge. This doesn't mean that the service stops. Edge DCs can still handle traffic, right, in a way or another, but the communication, the dialogue, any kind of new adjustment, any kind of governance is lost. That's why we see the edge cluster, standalone edge cluster, as more giving better high availability. From operational perspective, they believe that in the DCN approach, because you have a central brain and you have remote workers, you can just do the automatic configuration, the ZTP, the infrastructure as a code, the expansions in a very classic way, the same we do it on central DCs. While in the standalone edge clusters, people believe that you may have to go side by side, DC by DC, if you don't have the automation framework in place. So that's why the DCN looks a little bit better. From scalability, adding a new POP in the DCN, just adding a new compute nodes, it's a very classical process, but adding a new POP in the standalone edge cluster require structuring the full DC controllers and worker nodes. Second thing, it's a brownfield case, and that's a very important, most probably because most of the operators, they have on-prem clouds, so they have a central stack that have controllers, right, in the central sites. So if they want to go to the edge as a pilot or as a testing, they always prefer the DCN because they say, okay, let's go like having 1 or 2, 3 DCs, okay, capitalizing on the investment that we did on the central sites, and let's see, right? So that's always the starting point for brownfield cases. While in standalone edge cluster, it's a perfect fit for a greenfield, but brownfield, it's always preferred to go to the DCN. From operational tools of FCAPS, again, because the central DCs, they have the connectivity to the OSS and BSS. So again, most of the operators, they want to capitalize on that integration because people working on that part, it's one of the lengthy, painful integrations to integrate with the fault management, performance management to the OSS. That's why from operational tools perspective, DCN somehow is preferred. For interlocks with orchestration, and to be fair, and that's my opinion, it might look like DCN is a good approach because there are orchestration stacks are there and we can just extend the orchestration capability on the edge. However, on the edge, it can be a sweet spot to welcome new players, startups, or new solutions for orchestration that can integrate to the OSS at the end, or the end-to-end orchestration, or the multi-domain orchestration, or whatever. So that's why I didn't give a higher weight to someone. I believe that both of them are okay with terms of orchestration. If it's a DCN, then you capitalize on central orchestration stack and you extend the capability to the edge. If it's a standalone edge cluster, then you have like a new domain orchestration for edge, maybe coming from a new player, and then you integrate with the end-to-end SO. I have like 4 minutes. I'll just finish by this one because it's a very, very interesting. So if you go to study the case, for example, of AWS doing a partnership with Verizon. So first of all, if you want to get this service, you go to Amazon. So that's number one. So you as an enterprise customer, you like to go to Amazon, right? Because you are used to work with Amazon. So you can get edge services from Amazon the same way you get your cloud service, from AWS. So you go to AWS, and then you find that, okay, AWS is saying that we are there in these cities doing partnering with the CSP Verizon. Okay, so if you get the service from us, then you get it from Verizon. And from the definition itself, what AWS did, that they went to the, let me just find you the exact context, that they went to the CSP data centers at the edge. So they went to communication CSP data center at the edge, and they put their stack. Okay, so that you can get a full solution mixed by Verizon offering and AWS offering. But what is the good thing, and that's what I was stressing on, that when you get AWS wavelengths, you get these, right? You can easily get the machine learning SageMaker, right? You can get the AWS RoboMaker. So you get a full list of certified application on the edge. So it's not just a network part, an edge network part, a 5G part. No, you get a 5G from Verizon, but you get the whole list from Amazon, and that's Amazon environment, right? You can do anything under the title platform as a service. So that's the edge really that the hyperscaler they have, that they have a full stack of certified applications. They have a global presence globally. Yeah, imagine with me that if this customer get a service in Atlanta, and he has like a branch in South Korea, so he can get the same, because AWS is having the same partnership with an operator in South Korea, so he can get the same edge service in Atlanta and in South Korea. So that's a global footprint, and that's an edge of the hyperscalers on the compared to the typical CSP proposal, right? Because, for example, if I am giving, I'm a Vodafone UK, giving a service, most probably it will be in the UK, right? But AWS or hyperscaler help CSPs to have this kind of global footprint or global delivery. So guys, it's already 1 hour. First of all, I hope it was really beneficial for all of us. I tried to cover the topic from I would say market perspective, from standards perspective, and actually giving you the hint on what's happening on reality. And I end with a case study because that actually shows the trends about the edge. So there are a lot of questions, strategical questions to be answered. As a CSP, shall I expand my capability from the core to the edge? Shall I partner with a hyperscaler? Shall I go with the DCN approach? Shall I have like an on-prem deployment, or I go directly for enterprise edge, giving a private 5G on a box? There are a lot of questions to be discussed and to be answered. So we have like I can take some questions. Okay, about question, which of the vendors are offering DCN? So DCN mainly is well, the term is coming from Red Hat, so I would say Red Hat. The global footprint provided by hyperscaler is similar to GSMA MOM. Yes, but I would say the different, yani, because the global footprint is actually there from the hyperscaler, and GSMA is trying to having the same, but it's coming from the hyperscaler. Okay, okay, guys. I would like really to thank you. I personally enjoyed this one. It's always a pleasure to meet you, and I really like the questions. I'm sorry I couldn't go through all the questions, but I promise you that I will just collect all these questions and have it answered, and that we can use it all as a reference or as a frequently asked questions guide for the Edge. Uh, so if you have any final comments, I'm here. Yeah, thank you.